What up? I am the Wired Martian, and I know I haven't posted anything in a while. If you do follow my channel, but I've been backed up on some side projects, still backed up on some side projects. But I found a little bit of time to do another payment tutorial, and this one actually comes off from one of the projects that I had been doing. It is it is PayGate basically. So basically, in a nutshell, what we're gonna be doing is we're gonna be using PayGate to accept online payments. However, this one is different because this sort of payment will require a 3D verification. Also, this kind of payment does not redirect to PayGate's website where the payment is handled, and then they just return to a page in your web application to say, cool, here's what happened, here are your payment details. Also, unlike the video I made a while back about this section, Pay Web 3, which is where you redirect to their website and do the payments, that was a monolith application built using .NET C#. What we're gonna be using right now? So this is the one that I made a while ago. The one we're gonna be working on is also C#, but it uses .NET Core 3.1, and for it's an API, so it's not a monolith application. And for our client, we're gonna be using Angular. The reason I chose Angular is because Angular seems to be a bit popular, and everyone, well, at least in South Africa, it seems to be like a big deal. Anyway, enough talk. So I'll show you I'll show you a demo first, and then I will show you the code. Where is my demo? Okay, so this is my Angular application running on port 42. So we're not looking at PayWeb 3, we're looking at Payhost. So this is cool for if you want to handle the payments from your side and you have something like a mobile app where you cannot redirect outside of that app and then come back. It works in those kind of scenarios. And then we're gonna go to the testing section. So these are the cards you can use for approved transaction, insufficient funds, declined, whatever. All right, I'm gonna try it with the Mastercard first, and then I'm gonna open my dev tools because I like to know what's going on. Let's see if this is running. It is running. I'm using JetBrains Rider because I'm on Linux. I can't use Visual Studio. So I'm gonna put in my name. I'm gonna put in my surname, which is not my real surname. I'm gonna put in my card number. And the expiry, this is November 2023. I know this is not user-friendly, but this is really not what this is about. So the CVV could be anything. It's a testing environment. And I'm going to be paying 5 Rand. So this gets converted into cents. Right? So, and if we hit pay, it's processing. So it's done, and then what you get basically is this. It tells you like, okay, the payment was completed. Did it require 3D verification? Probably not. And then here's a pay request ID. So this is the information coming from my API here, and my API gets it from PayGate. So when you're making this payment on PayGate, you can also choose whether you want to vault the card or not. So vaulting is saying, I want to vault this information, and instead of having to put in my name, surname, my card number, and whatever, the next time I have to pay on this similar application, I will just provide this vault ID and my CVV, and then it will just process the payment, right? So ideally, you store this on your database somewhere. Okay, so this was a Mastercard. Now, if we try a Visa, you're gonna see something a little bit different. So we're gonna try a Visa card, right? And then we hit pay. Okay, so you'll notice this one has taken me here. So it's saying, cool, this is where 3D verification comes in, where you would put in your one-time PIN or whatever. But in this case, they rendered, if we look at our, oh, sorry, yeah, I was looking at the request. If we look at the response here, this is what the response, the completed, it's false. So it's not, this payment has not been completed. And this is the 3D secure verification HTML. So this page, this content is what's being rendered here, right? So this would be where you put in your OTP or whatever it is. So basically you verify on the app with your bank or whatever, right? So we're just gonna assume this is our one-time PIN and we hit submit. And it processes the payment. And this should change to the new. Okay, and then we get the information back saying, here's a transaction, here is a reference, here's my pay request ID. And if you look here, here's my the pay request ID that I received, E9FD, with the HTML. So this one is it's a 3D verification, so it's been verified. This payment is verified. So in an instance where you don't want someone else using your card, so, or if someone else was using your card, it will prompt on your phone to say, hey, someone is trying to use your card. Do you want to accept this transaction? You would say, nah, I don't know who this is, or whatever. Okay, so I'll explain the layout of my application first, and before I dive into the code. Also, before I forget, if you're looking to just get into the code, you can go to my GitHub, wiredmartian/Payhost. I have this application there. It will tell you everything you need to get it running. I decided to put both applications, the Angular app and the .NET Core app, within one repo for convenience. So you're gonna need this, and you're gonna need this other thing as well. I'll explain what it is. But basically it's WebSockets. It's a socket service. It solves the problem. Okay, so basically what we have is, we have our client, our Angular application. We have our API, which is this API. And then we have PayGate, which is our payment gateway, these guys. And lastly, we have this socket thing here. So I'll just put an S here. All right. So I'll explain the first kind of payment, the Mastercard, which doesn't require any extra verification. And then I'll explain the other one, the 3D verification sort of payment. Okay, I'm not entirely sure what happened here. There. I'll just use this one. Okay, so with the Mastercard, basically, we send our information to the API, right? There, which is here. And then in turn, our API makes a request to PayGate. This is for a Mastercard. I'll just say you can always back forward this or whatever. So our API makes a request to PayGate, and then PayGate processes that payment and then sends the information back to our API to say, hey, your payment was successful or your payment was not successful. And then PayGate sends that information they received. Our API sends that information it received from PayGate to our client. And then the client basically displays the results. Okay, so that is for a Mastercard. For a Visa, where a 3D verification is required, the process is somewhat like this. Same, we send a request to our API, right? Our API sends a request to PayGate, right? PayGate processes this payment and says, hey, this payment requires 3D verification. And then our API says, oh, okay. So PayGate sends this information back to our API, says this requires a 3D verification. If you want to see a page which will display this 3D verification, here's the URL for it. Here's what you need to pass to it. PayGate gives that information. Our API says, okay, I'm going to make a request then to that page that you gave me and pass all this other thing, which is a post. And then PayGate receives that information and then sends back the page to our API, which is the page that has, which is this page. So it sends back this page, right? Sends back this page. And then my API says, cool, client, here you go. PayGate has told me that this payment needs 3D verification. I've asked them for the page and they've given it to me. Here it is. Please put in your OTP, right? Our client, yeah, this is becoming very messy. Sorry. Our client says, okay, that's cool. Our client takes this page. Sorry, our page which we have here, and then it also receives back this pay request ID and response whatever. So our client takes this page and renders it on the UI. So that Visa page you saw, it takes that page, this HTML, this HTML, and renders it here. Right, and says to the user, please put in your OTP or whatever it is. And then after rendering the page, it creates a room. It creates a socket room and then names that room after the pay request ID, right? So this is the stuff you see here. See here, it connects to a socket service, socket server, which is this. Once it's connected, it creates a room and it names that room according to the pay request ID. So the pay request ID of the current payment, so the GUID, to make sure that that room is always unique and it can only be joined by one person pay payment request, right? So that's what it does. It renders the page. It connects to a socket service, which is this socket server, and then it makes a room based on the pay request ID. Okay. So now when this page is rendered, the person verifies it, and since that page would now will directly hit PayGate, right? And then PayGate will then process this payment to say, cool, do you have funds? Did the one-time PIN you entered, was it correct? Was this 3D verification successful? When it's successful, PayGate cannot send a request back to our client here to say that the payment was successful. So in turn, PayGate uses something they call a return URL. Oh wait, actually it's right here. I can find it here. PayGate uses something they call a return URL. So you're basically saying for each request, you're saying when the payment is successful, please return to this URL, and please send the status of the request to this URL. So return to this URL, send the status of that of this payment to this URL. So this is a get where payment returns to, PayGate returns to. This is a post where they post that information, right? So PayGate cannot talk back now to the client to say your thing was successful, right? So they now use that notify URL, and then they post this data to that notify URL, right? To that webhook. They call it a webhook. But the webhook is actually the notify URL and the return URL are both endpoints on this socket service. So in a nutshell, if we do PM2 here, sorry, to PM2 logs, you should see something really cool. So there's an endpoint here that PayGate uses, which is a webhook. So PayGate comes and hit this with this information, sends this information to that. So the pay request ID, if we open this and scroll further down, by the way, this has to be live. Your return URL and your post URL have to be live. They can run on localhost, otherwise it's not going to work. So if you could see here, we have this pay request ID, which is the same as this pay request ID, and the status of this payment and the checksum in case you want to re-verify it, right? So PayGate posts this information on this endpoint, right? When this post endpoint is hit, it takes the pay request ID, which it receives from PayGate when they were posting that data, which is the same ID that our client opened a socket, opened a room that is named after. So PayGate hits this, and then that endpoint then emits a message saying this payment is complete. And the room it emits to is the room that this client opened. And the reason it knows that room is because PayGate has told it, like, this is the pay request ID, which you opened the client, which you opened the socket with. So our socket service then tells our client, like, hey, the payment is successful, right? When our client receives that message, it takes that pay request ID and says, cool, give me more information then, because so when that client gets that message emitted into that room, it makes another request to our API, passing the pay request ID to say, give me more details about this transaction. Our API goes to PayGate and looks up the transaction by the pay request ID. And then PayGate returns that information to our API returns it to our client, and our client displays that information and says, cool, everything is good. So that is how 3D verification works. It sounds very complicated when you're explaining it or when you're trying to solve the problem, but the code isn't that complicated. Right, now to go to the code. Heading over to the code, so we have a controller called the pay controller. We have a model where basically I get that information from here. And then we have another model, which is a response model. So how I return that information to the user, basically. If we look at response, so response, pay request ID, secure 3D, which is what we have here. I'm going to make this bigger, which is what we have here. And then we have the client, which is the Angular application. We have services, which is the payment service. So this is where the magic happens. And then we have this thing here called templates. Okay. Now I'm going to show you PayGate's API. So if you go to C#. So for an example, let's take this one for an example, right? So if we make this bigger. So what you see here is actually it's the body that get posted to PayGate whenever we do this. So it uses something called web service. I don't remember the thing it's called, but basically it just accepts XML. You need to send XML information to it. You can do it this way, where you do like string concatenation, but I'm not a huge fan of string concatenation. So what I did is all the requests that I am going to be sending to PayGate, where this one is for payment, I just created an XML file, and what I do is I just load that to my code, load that to my application. So an example is this. I just load it, read the body, and replace all of these with actual values. So for an example, this curly braces first name, curly braces first name. This is when you want to vault the request. This is for checking the status of a transaction. So basically what I did is I just copied whatever I needed from these templates. Okay, so as far as that is concerned, that is what I have. And then on my startup file, I am just registering that service, registering this service, which is this one here, and here's the interface for it right here. Registering service, and then take care of cause, and I'm just allowing everything, and then you use cause. Okay, so if we go to my service here, or we start off with my interface, here's my interface. My interface has where you add a new card, which is this form right here. You add a new card, and then you can get a card by Vault ID. So for an example, if I do, here's what I had here. I had a Vault. I think I have a Vault ID somewhere. I have a Vault ID here. You pass the Vault ID. Yeah, so if I hit send, yeah, basically you get your card information back. 11/20/24, 11/20/24. So it's the same card. So if you wanna look up if a vault still exists before doing a payment using that vault, then you would have that sort of functionality. Okay, cool. So that's what that does. It gets a vaulted card, and this query transaction where you pass a pay request ID is basically, if I take this pay request ID here, this is the part where I said once the socket emits a complete message to a client's room, the client then takes the pay request ID and then looks up the results of that transaction. So if I go back to Insomnia again and do I put in my pay request ID and I do query here, hit send. So it should give me the exact information as this other information right here. So for an example, transaction ID 333, as you can see, it's pretty much the same kind of thing. Okay, so basically I have those three functionalities here, and they all stated this in the service. The URL, where the URL to PayGate is also specified here. It's this one. It seems to always been. It's always a post. So just like they have it here. So for an example here, let's see how I implemented this. I'll just walk you through one function and you should get it. So a web service which implements or implements this interface. So I have the REST client. This is what I'll use to make HTTP request. The default constructor, I'm instantiating it and then passing that URL from PayGate, which is the same URL, Okay, and then I'm constructing my request here, so, my response, to say this is what my response would look like. By default, it's not completed. So the request, and then I make it, and then I form a request. So the request is a post, just like you saw here. It has to be a post. Content type is XML, and I'm invoking a function called web payment. To be honest, I think it's a SOAP action called web payment request, but I'm not entirely sure. I don't know how SOAP works, but they did it something similar here. Right. And then what I do is then I load my body structure. So I load this file here, single payment request. So I load this file. So I load that file, read it into this property, and then keep replacing all these keys with actual values. So first name, card, first name, which is passed here, the card. So first name, last name, mobile. Some of the stuff I left blank because if you look at this file, like I have the pay request ID, I have the password. So it won't replace those because in a nutshell, this doesn't exist in that file. There isn't something like this in that file. But it just replaces whatever it could find. So email, card number, card expiration, CVV. The merchant order ID is basically a payment reference. It could be anything, but I think it has to be unique. I'm not entirely sure. The amount you're paying has to be in cents. So in this case, I'm saying that amount might be maybe 5 rands. You multiply it by 100 to get it in cents, because this value has to be an integer. It cannot be a decimal. If it's a decimal, it's going to break. And then basically I do this, pass all this body to the request, execute it. And here I'm giving you an example of a response you're going to get back. So the response looks something like this. Wait, actually I could just show you now. I'm going to put a breakpoint here. It doesn't exactly look like this, but when you convert it to JSON, it looks like this. So I'll do that later. And I have this function called okay, I guess I have to do this. Okay, I'll show it to you just now. Let's run this on debug mode. Next. So execute the function, make the HTTP request, which takes a while, but it's not my application that's slow. It's I don't want to blame PayGate. Okay, so the response you get back from that execution looks something like this. I wonder if I could change it to, oh, it's a read only. Okay, so it looks something like this. I'm gonna grab Kate. I'm interested in this and here. Okay, so the response looks something like this. And basically what this is saying is on that response, so if I go to this, let me just go to this function, map response to object. It's a private function which accepts some keys. So I'm basically converting this XML response that I have here to JSON. And then I am using regex to remove all the ns2 because I don't want those. So all the ns2 thingies, I don't know what those are, but I do not want them. And I'm saying cool, once you've removed those and turned this response into JSON, look inside SOAP env envelope and get what's inside the body. So that is this something envelope. Look what's inside the body, and this is what's inside the body. Right? And then I'm saying after you get what's inside that body, look at response keys if there are any. If there are any response keys, then inside this response object that I now have, inside that I have now removed the envelope and the body and trimmed the ns2, get me what's inside single response. So what's inside single response, and then inside single response get me what's single payment response, and then inside single payment response get me card payment response, right? And then all it does, then it just returns that object. So this is like an iteration of some kind, aggregate functions. So that's what it's doing. So it's mapping, trimming, giving me the data that I need, so that the response then looks like this. So it comes back as this JSON from this manipulation, right? And from that result, I'm saying cool, if it has a status, get the status, look, check the status name, which is here. Okay, it could be completed, it could be an error, or it could be like it requires 3D verification, right? So if it's an error, I'll just throw an application exception. I'm not doing anything with it. If it's completed, I look at the result code. I look at the result code. The result code is here somewhere. I look at the result code. And then if it's completed and the result code is not equal to the result code is not now, so this is the case when it's complete, when the case is completed and the result code isn't now, I want to execute this section. So the 990017 means that this transaction was successful. You can find these payment statuses on PayGate. We go on PayGate. So I'm interested in this one specifically because that says the payment is successful. I return else. If it's not successful, throw an application exception with that result code. It's probably declined, but it could be something. Could be something else. Could be more specific, like, oh, it's a lost card, it's invalid length, it's restricted card, whatever. But if it does require 3D verification, then do some different things. So just like I explained before in this section, before it got really messed up. Sorry, I had to pause this video because I wanted to do something. So if I do get this one, so just like the part where I said, well, if PayGate tells my app that, hey, this thing requires 3D verification, if you want 3D verification, here's some information that you need to make a request to, and I'll send you the page. And then my API sends that request, and then PayGate gives my API that page, and my API sends that page to the client. This is basically what I was talking about here. This is what's happening here. So it has a redirect tag and then URL params that I will need for that redirect and the URL. And I'm basically stripping out that information from there. So let's make this visa request so we can see that information that comes. Okay, so it requires 3D verification. CX, URL params. So if we look at, if I can just make this bigger, if we look at here, I think this is what we're interested in. So this is what PayGate returns to my API to say, hey, 3D verification is required. Please make a request to a URL and pass this information. So here's that information that you need to pass. Basically, yeah, that's the information you need to pass. And the redirect URL is this one. It's right here. Cool. So that's basically what I'm doing. Then I'm making that request again, executing it. So that will get me back the HTML page. And I'm saying if it's not successful, then throw that error. If it is successful, cool. The contents then that gets returned back is basically this HTML page, and this is the HTML page that I render where the user puts in their OTP or whatever it is, and then basically I'm just returning everything else. It's completed, it's not yet completed, the pay request ID, response, yada yada. Okay, so all these other methods pretty much follow more or less the same structure. When you want to get a vault ID, same kind of structure. When you want to query a transaction status, same kind of deal. Okay, so if we move to our controller, there's nothing much that's happening here as well. We're just basically making sure we get our service, and when we're adding a card, just make sure that the model is valid. If it's not valid, returns the first error message that it finds. It makes a request. If everything is good, it returns it. And then I have a catch for an application exception and a catch for a general exception where I throw in a 500 because I don't know what happened here, but I have an idea what happened here because I'm the one throwing the application exceptions. Same thing when you're vaulting, and same thing when you're querying a transaction as well. It's basically just calling those functions from there, looking for any exceptions. Okay, and when we're looking at the client side, this is my Angular client. So this is also straightforward. I have an API, so my service, this is where I make requests to my API. This is the URL to my API. This is the URL to my socket service. So basically, post request to add a card, query, transaction, the stuff you saw from here. Basically, I'm just making requests from there. The stuff you saw here, except I'm making them from an Angular side. So this is what that is doing. This is the part that's interesting, however, where I'm connecting to an IO server or like a WebSocket server, and I'm passing a query string of name pay request, and I'm passing a value of the pay request ID value. So if I go to, this is the this is the section where I said the client connects to a WebSocket service and then creates a room and then names that room according to the pay request ID. And if we look at this, the socket service, it's a Fastify. It's a Fastify service. Basically, it's a socket service that listens for connections, any specific type of connections. Well, not just any connections. Well, any connection, I think, actually. But it's very much interested in the query parameter that gets passed, because it uses that to create a room, right? It uses that to create a room based on the pay request ID. And then it emits a message to that room saying joined. So that's saying you have joined, everything is good, it's connected, right? And then from here, so when PayGate returns here, it hits the webhook, which hits my service. These are the routes that PayGate hits. So this is the return URL that I gave PayGate, and this is the notify URL, where they tell me like the status of the transaction. They give me the information about the transaction. So if you could see here, I'm console logging the body that I get from PayGate, and then I'm taking the pay request ID from that body, and I'm emitting to a room based on this pay request ID a message called complete, and I'm passing in this information, the pay request ID. So I'm basically saying, okay, this payment is complete because I got that message from PayGate. So if we come here, then where I open that socket, so I was listening to all those messages. If we go to pay stuff, where I connect to that service, so I call this function here to connect to that socket, and then I listen to any messages. So I listen to these specific events: message, joined, complete. But I'm very much interested in this one. So when I get this message that's emitted to this room from here, from my socket service, I set the secure 3D HTML to now because we no longer need it. And then I run this complete follow-up request. So what this is basically doing is saying, cool, since this payment was complete, I'm just gonna look up the full information of that transaction to my API, to the API that I made. So basically this is what this is doing. That's when someone clicks pay, it just does this. Makes a request, sees if it's completed. If it's completed, just displays that information. If it's not completed, but it didn't return a 400 or 500, then it probably means that it needs 3D secure. And then I take that HTML, pass it to this, and I use this bypass security trust resource to say, I trust this HTML resource. It's a security thing, just bypass it. So once I do, like I said here, once I do render this page, then I'd open like a connection, WebSocket connection to my service, which is what it's doing here. And the HTML is pretty straightforward. So this is pretty much how you do it. And if you want to port this into Vue, it's pretty much more or less the same when it comes to your UI. But anything else in terms of services doesn't change. You still use this sort of like socket service, and you'd still use this sort of like API. Okay, I hope you learned something. And do hit the subscribe button. I might come back with more content sometime that may not be payment related, but it's good to keep the channel running.